Here we have a problem on complex number in IIT JEE Main Mathematics. Okay, let's go to the question. Let integers a comma b belongs to the closed interval -3 comma 3 be such that a positive b is not equal to 0. Then the number of all possible ordered pairs a comma b for which observable of z negative a over z positive b equals to 1. And here we have a determinant that is equal to 1 where z is a complex number, where omega and omega square are the roots of x square positive x positive 1 equals to 0 is equal to. Okay, the target of the question is to find the number of all possible ordered pairs a comma b. For that, we have three information over here. There is observed value equation over here, and here we have a determinant, its value is 1, and here we have that omega and omega square are the two roots of the quadratic equation over here. Okay, and also a comma b, both of them must be integers, and they must be in this closed interval -3 comma positive 3. Okay, now what we have to do is we have to plan how to solve this problem. So here we have absolute value of z negative a over z positive b equals to 1. So I must be knowing the value of the complex number z, so that I can plug in the value of z over here, and I can solve for a and b, and I'll be able to get the number of all possible ordered pairs, that is a comma b. Okay, to get the value of z, we have to use the determinant we have over here, determinant equation. It is the value of this determinant equals to 1. And also to find value of z using this determinant, we have to find the connection between the two values omega and omega square. So we can use the last piece of information to get some connection between the two values omega and omega square. Once I get the connection between these two values, I can use that stuff over here in this determinant equation and find the value of z. Okay, now let me consider this particular piece of information. There is a quadratic equation x square positive x positive 1 equals to 0 has two roots omega and omega square. Okay, now let me find the sum of the two roots of this quadratic equation, that is omega positive omega square. Okay, there is a quadratic equation in standard form. There is a formula to get sum of the two roots, that is negative b over a. Actually, this b is the coefficient of x, in this case it's 1, and this a is the coefficient of x square, that is also 1. Okay, so we have negative 1 over 1, then we get omega positive omega square equals to negative 1 over 1 is just negative 1. Okay, now let me add 1 to both sides. When I add 1 to both sides, negative 1 positive 1 will cancel out, then I'm getting 1 positive omega square on the left side. On the right side we have 0. Okay, now let me get the product of two roots of this quadratic equation. The product means we have to multiply the two roots, that is omega times omega square, that is equal to c over a. C is a constant term, in this case it's 1, and a is a coefficient of x square, that is also 1. Then we get 1 over 1. When I multiply this omega and omega square, I am getting omega cube equals to 1 over 1 is just 1. Okay, here we have to notice an important information. We have the sum of the three values 1, omega and omega square equals to 0, and the value of omega cube equals to 1. So whenever the sum of the three values 1, omega and omega square equals to 0 and omega cube equals to 1, we have to understand that 1 omega and omega square are the cube roots of 1. Let me write the stuff over here, are the cube roots of 1, and in these three cube roots of 1, so only the first one is integer, the remaining two are complex numbers. So that is omega is a complex number, omega square is also a complex number, and omega equals to negative 1 over 2 positive I times square root of 3 over 2, and omega square equals to negative 1 over 2 negative I square root of 3 over 2. Okay, now we got some stuff when I use the last piece of information. Okay, now what I'm going to do is I'm going to take this determinant and find the value of z. Okay, let me continue on the next page. Here I have taken the given determinant equation. I'm going to find the value of this determinant. For that, I'm going to expand this determinant using the elements in the first row. Okay, let me take the first element of the first row, that is z positive 1. Okay, now I have to eliminate the corresponding row and corresponding column. Now I have to multiply these two values. Okay, let me do it. Then I'm getting z positive omega square times z positive omega. Now I have to take a negative sign. I have to multiply these two values. So 1 times 1 is just 1. Okay, now let me take a negative sign, and I have to consider the second element of the first row, that is omega. Now I have to eliminate the corresponding row and corresponding column. Now I have to multiply these two values. Then I'm getting omega times z positive omega negative. I have to multiply these two values, omega square times 1 is just omega square. Now I have to take positive sign, the third element of the first row, that is omega square times, I have to eliminate the corresponding column and corresponding row. I have to multiply these two values, take negative sign, and then multiply these two values. Okay, let me do it. Then first let me multiply this omega and 1, then I'm getting omega negative. Okay, now I have to multiply these two values and I'm getting omega square times z positive omega square. On the right side we have 1. Okay, now z positive 1 times, let me multiply that two binomials we have over here. So z times z is z square and z times omega is z omega. Let me write it. And now let's multiply this omega square and z, then I'm getting positive z omega square. When I multiply this omega square and omega, I'm getting positive omega to the third power. Actually, already we know that omega cube equals to 1. We got this result on the previous page. So instead of writing omega cube, we can write to 1 and we can write this negative 1 as it is. Negative omega times, now we can distribute this, this omega to the z and omega, then I'm getting z omega positive omega times omega, it is omega square, and we can write this one as it is, that is a negative omega square positive omega square times omega negative, we can negative omega square can be distributed to these two terms inside the parentheses. Negative omega square times z is negative z omega square, and negative times positive will become negative. Omega square times omega square is omega to the fourth power. Let me write it over here, equals to 1. Okay, here this positive one, negative one will cancel out. Positive omega square, negative omega square will cancel out. Then we have z positive 1 times z square positive z omega square. Okay, here we have negative omega times z omega positive omega square times omega negative z omega square negative, and let me consider this omega to the fourth power. Omega to the fourth power can be written as omega times omega cube, because the product of omega and omega cube equals to omega to the fourth power. Already we got the value of omega cube in our previous working, that is 1. So omega times 1 is just omega. So omega to the fourth power equals to omega. So we can plug in omega for this omega to the fourth power and equals to 1. Okay, now what we can do is we can multiply this binomial and trinomial. Let me distribute this z to all the terms inside the parenthesis over here. Then z times z square is z to the third power. Z times a positive z omega, I'm getting z square omega positive z square omega square. Now I have distributed z to all the terms over here. Now let me distribute this positive one to all the terms inside the parenthesis over here. Then I'll be getting the same stuff, because I multiply all the terms by 1. Then I'm getting positive z square, positive z omega square. Okay, when I multiply this negative omega and this z omega, I'm getting negative z omega square. Now I can distribute this omega square to all the terms inside the parenthesis over here. When I distribute this positive omega square to this omega, I'm getting positive omega to the third power. But we know that the omega cube equals to 1, so we can write 1 instead of omega cube. When I multiply this positive and negative, I'm getting negative omega square to the, when I multiply this omega square and this z omega square, I'm getting z times omega to the fourth power. But for this omega to the fourth power, we know that it's omega, so we can write just omega instead of omega to the fourth power. And now when I multiply this positive omega square and negative omega, I'm getting negative omega to the third power. But we know that the value of omega cube is just 1. We can plug in 1 over here. Now let's do some more simplification. So here what we can do is we can cancel out this positive z omega, negative z omega, positive z omega square, negative z omega square, positive 1 and negative 1 will cancel out. Then I'm getting z to the third power. And when I look at these three terms, all the three terms have the greatest common divisor z square, so we can factor z square out. When I factor z square out, then I'm getting omega left in the first term, and in the second term I have omega square, and in the third term I'm just getting 1 equals to 1. Okay, already we know the result of this expression, that is the sum of omega square and 1 equals to 0. So we can plug in 0 for this one. When I do so, I am getting z cube positive z square times 0 equals to 1. Okay, then z square times 0 is 0. So 0 positive z cube is z cube equals to 1. Okay, let me continue over here. We got that z cube equals to 1. So my aim is to get the value of z. For that, we have to get of this exponent 3. For that, we have to raise both sides of this equation to the power of 1/3. Let me do it. Z cube raised to the power of 1/3, and the right side also I have to raise 1 to the power of 1/3. So here what we can do is we can multiply these two exponents using the power of a power rule in exponents. Then I'm getting 3 times 1/3 equals to 1 to the power of 1/3. So here this 3 will cancel. Finally, I'm getting z to the first part is just z equals to 1 raised to the power of 1/3. Okay, now I got z equals to 1 to the power of 1/3. Actually, this 1 raised to the power of 1/3 represents the cube root of 1. So therefore, z is the cube root of 1. When z is a cube root of 1, we have z equals to 1 omega square, and already we have discussed this stuff in our previous working, and also we know the value of omega and omega square. We have to remember this, when 1 omega and omega square are the cube roots of 1, then we have z equals to 1, and for omega we know that negative 1 over 2 positive I times square root of 3 over 2, and for omega square we have negative 1 over 2 negative I times square root of 3 over 2. Okay, so as we have planned, we got the value of z. Now what we have to do is we have to consider the equation given in the question, that is absolute value of z negative a over z positive b equals to 1. Okay, now let me take this equation. So absolute value of z negative a over z positive b equals to 1. Okay, now whenever we have absolute sign for a fraction, what we can do is we can take the absolute sign for numerator and denominator. Then I am getting absolute value of z negative a divided by absolute value of z positive b equals to 1. Okay, now let me multiply both sides by the stuff what we have in the denominator, because I want to get rid of this denominator. Then I'm getting I multiply both sides of this equation by absolute value of z positive b. Let me do it on the right side. Okay, when I do so, this one will cancel out. Then I'm getting absolute value of z negative a equals to 1 times this one is the same, that is absolute value of z positive b. Now in this equation, we have to plug in the three values of z one by one and solve for a and b. Okay, now let me plug in the first value of z, that is 1. Let me write the equation. So for this z over here and here, I have to plug in 1. Then I'm getting absolute value of 1 negative a equals to absolute value of 1 positive b. Okay, here in this equation we have absolute sign on both sides and all of them are integers. Here the one is integer. According to the instruction we have in the question, both a and b are integers. Okay, whenever I want to solve an equation which contains absolute sign on both sides, it has to be solved in two parts. Okay, in the first part, what I have to do is I have to take the stuff inside the absolute sign on both sides as it is without absolute sign. That is, we have 1 negative a equals to 1 positive b. In the second part, what I have to do is I have to take the stuff inside the absolute sign on the left side as it is, and before I take the stuff inside the absolute sign on the right side, I have to take negative sign, and now take the stuff inside the absolute sign, that is 1 positive b. So this is a method to solve an equation which contains absolute sign on both sides. Okay, now let's solve this one. So for that, what I'm going to do is I'm going to subtract 1 from both sides. When I subtract 1 from both sides, this 1 negative 1 will cancel, this 1 negative 1 will cancel. I'm getting negative a equals to positive which is b. Now let me add a to both sides. When I add a to both sides, is negative a positive will cancel. I'm getting 0 equals to a positive b. Okay, here let's solve this one. 1 negative a equals to, when I distribute this negative sign to this and this, I'm getting negative 1 negative b. Okay, now let me add 1 to both sides. When I add 1 to both sides, is negative 1 positive 1 will cancel out. Here 1 positive 1 is 2 negative a equals to negative b. Now let me add a to both sides. When I add a to both sides, negative a positive will cancel. I'm getting 2 equals to a negative b. Okay, now what I can do is I can solve for a in this equation. For that, we have to add b to both sides. When I add b to both sides, this negative b positive b will cancel. I am getting 2 positive b. Otherwise, it can be written as b positive 2 equals to a. Okay, here when I solve this equation, I am getting two results. One result is 0 equals to a positive b, and other result is b positive 2 equals to a, or it can be written also a equals to b positive 2. I cannot accept this result because here the value of a positive b is 0. According to the instruction, a positive b cannot be 0. So we can reject the first result because it does not satisfy the condition we have in the question. Let's consider this one, a equals to b positive 2. So in this equation, we have to solve for a and b with the condition both a and b must be integers and they must be in the closed interval negative 3 comma positive 3. Okay, let me do this one on the next page. So we have a and b, both of them are integers, both of them are in the closed interval negative 3 comma positive 3, and we got the result that a equals to b positive 2. Let me write that one too, a equals to b positive 2. Okay, now let me draw a number line. So here we have negative 3 and the right end is positive 3. So let me take negative 2, negative 1, 0, 1, 2. Okay, since it's a closed interval, we can consider the boundary values also. The left side boundary negative 3 and the right side boundary positive 3. Both of them can be included. So here let's count the number of integers we have over here. There are 7 integers we have over here. Okay, now what I'm going to do is I'm going to take the first integer value negative 3 for b over here. Okay, let me take it b equals to negative 3. When I take b is equal to negative 3, what value to get for a? So when I plug in b is equal to negative 3 over here, negative 3 positive will become negative 1. I'm getting a equals to negative 1. So the first pair I'm getting, that is for a comma b, negative 1 comma negative 3. And now let me take the second integer value for b, that is b equals to -2. When I plug in b equals to -2 positive becomes 0, that is the value of a becomes 0. Then the second order for a comma b we have 0 comma -2. And now let me take the third integer value -1. Then I take b is equal to -1 over here. -1 positive will become just positive 1. Then I'm getting a is 1 and b is -1. Let me take the next value 0 for b over here. So b equals to 0. Then I'm getting a equals to 2. Then I'm getting 2 comma 0. Okay, now let me take the next value 1 for b. Then I'm getting b equals to 1. Then a equals to, when I take b is equal to 1 positive 2 is 3. Then I'm getting 1 comma 3. And now let me take the next value 2 for b. So b equals to 2. Then we get a equals to 2 positive 2 is 4. Then we get 4 comma 2. The value of a is 4 and the value of b is 2. Let me take the last value of b, that is b equals to 3. When I take b equals to 3, I'm getting a equals to 3 plus 2 is 5. Then I'm getting 5 comma 3. Okay, now we have to check all these ordered pairs we have for a comma b satisfy the conditions given in the question. That is a positive b cannot be 0. So if there is any ordered pair where a and b add up to 0, we have to reject that one. And also in each ordered pair, the minimum value of a has to be -3, maximum value has to be +3. The same condition for b as well. Okay, here if I consider the first pair, when I add -1, -3, does not become 0, and this one also does not become 0. But when I consider 1 and -1, the value of a is 1, the value of b is -1. When I add these two values, it becomes 0. That is a positive b becomes 0. It does not satisfy the condition we have over here. So we can reject this order pair. So the first one is okay, the second one is okay, this one is also okay, this one is also okay. But when I consider this one, the value of a is 4. It's out of the given interval. So we can reject this one. And in this one also, the value of a is 5. That is out of this interval. We can reject this one. So finally, we get how many order pairs over here? 1, 2, 3, 4. So when I use z equals 1, because I got 3 values for z over here, 1, here 1, this one and this one. When I use the first value for z over here in this equation, I got 4 ordered pairs for a comma b, which meet the two conditions given in the question. That is a positive b is not equal to 0, and both a and b are integers, and also the values of a and b are in this closed interval. Okay, now what we have is we have to take the second value of z, that is -1 over 2 positive I squared of 3 over 2 in this equation. Okay, now let me continue this one on the next page. Okay, let me plug in the second value of z over here and here. Okay, then we get -1 over 2 positive I times square root of 3 over 2 negative a equals to observed value for -1 over 2 positive I times square root of 3 over 2 positive b. Okay, now we know that a and b, both of them are integers, and this one contains I, that is, this is imaginary. Let's write the real stuff together. That is, we can take this negative a in front of everything. Then I'm getting negative a, -1 over 2. So this is actually real. Positive I times square root of 3 over 2. So here absolute value of, we can take this b in front of everything. Then I'm getting b -1 over 2. So this is actually real, because none of these two terms does contain I. Positive I times square root of 3 over 2. Okay, here we find a modulus of a complex number on the left side and the right side as well. So let me consider a positive ib in this way. So when I want to find the modulus of a complex number, what I have to do is I have to take square root, and the real part has to be squared, a square, and the imaginary part means a coefficient of I, that is b square. So this is the formula we have to get the modulus of a complex number. So we can apply the same stuff over here. So here we find the modulus of a complex number. So I have to take square root. The real part has to be square, that is negative a, -1 over 2, the whole square. Then imaginary part, that is square root of 3 over 2, the whole square. On the right side also we have square root of b -1 over 2, the whole square, positive, the coefficient of I, that is square root of 3 over 2, the whole square. Okay, when I take a square on both sides, so both the square roots will cancel. The square root on the left side and the square root on the right side will cancel out when I square both sides. And also here we have the square of a binomial, and both the terms inside the parentheses are negative. When I take square of a binomial, both the values are negative. What we can do is we can change them to positive, because when we have negative a, -1 over 2, the whole square, what we can do is we can factor negative sign out from these two terms. So then we get a positive 1 over 2, the whole square. since we square a negative value, it will become positive, then we just get a positive 1 over 2 the whole square. Okay, let me continue this stuff over here. Then we get a positive 1 over 2 the whole square, positive square root of 3 let me write this one as it is. It is a positive square root of 3 over 2 the whole square equals to b negative 1 over 2 the whole square, positive square root of 3 over 2 the whole square can be written as it is. Let me write it. Okay, now when I subtract square root of 3 over 2 the whole square from both sides, this one and this one will cancel out. So we get a positive 1 over 2 the whole square equals to b negative 1 over 2 the whole square. Whenever two terms are equal with the same exponent, what we can do is we can equate the bases. Here the term on the left side is having the exponent 2, on the right side also we have exponent 2. Since these two terms are equal with the same exponent 2, what we can do is we can equate the bases. Then I am getting a positive 1 over 2 equals to b negative 1 over 2. Okay, now let me subtract 1 over 2 from both sides. When I do so, this positive 1 over 2, negative 1 over 2 will cancel. Then I'm getting a on the left side. On the right side, we have b. When I combine this negative 1 over 2 and negative 1 over 2, I'm getting negative 1. Okay, now I've solved for a in terms of b. That is, I got a equals to b negative 1. Now, whatever stuff I have done on this on this page, that is, I have taken the 7 integer values from negative 3 to positive 3 for b and solved for a. The same thing I have to do with this equation. That is, first I have to take a b equals to negative 3. When I take b equals to negative 3, I am getting a equals to negative 3, negative 1, so which is negative 4. So here the value of a is out of the interval negative 3, positive 3. The closed interval already we have discussed, that is given in the question. Both the values of a and b must be integers and also they must be in this closed interval. Since the value of a is out of this interval, what we can do is we can reject a b equals to negative 3. Now let me take a b equals to negative 2, the next value of the next integer value of b. When I take b is equal to negative 2, then I'm getting a equals to, when I plug in b equals to negative 2, negative 1 will become negative 3. Then the order pair I'm getting for a comma b is negative 3. The value of a and b is negative 2. Let me take the next integer value of b, that is b equals to negative 1. Then I'm getting a equals to negative 1. Negative 1 will become negative 2. Then the next order pair is negative 2 comma negative 1. Okay, now let me take the next value for b, that is 0. When I plug in b is equal to 0, then I'm getting a equals to negative 1. Then negative 1 comma 0. Then we can take b equals to 1. When I take b equals to 1, negative 1 is 0. That is a equals to 0. Then I'm getting 0 comma 1. Okay, now let me take a b equals to 2. When I take b equals to 2, 2 negative 1, that is I'm getting a equals to 1. Then I'm getting 1 comma 2. Okay, now let me take the last value of b in the closed interval, that is 3. When I take b equals to 3, 3 negative 1 is 2. That is a equals to 2 and I'm getting 2 comma 3. And also we have to make sure in all the order pairs of a comma b, so they have to meet the two conditions, that is a positive b should not be equal to 0 and all the values of a and b must be in this closed interval. So let me check the first one. So negative 3, negative 2, this one is okay, this 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 is okay. Okay, now all the order pairs we have the values of a and b in this closed intervals, and also now all the order pairs sum of a and b is not equal to 0. So how many such order pairs I got over here? I got 1, 2, 3, 4, 5, 6. Okay, here I got 6 order pairs for a comma b. When I take the second value of z, that is negative 1 over 2 positive I square root of 3 over 2 for z in this equation. Okay, we have one more value for z, that is z equals to negative 1 over 2 negative I square root of 3 over 2. Okay, when I plug in this value for z over here and here, so this I square root of 3 over 2 will be negative. Here it will be negative, here it will be negative. Otherwise, we'll have the same negative 1 over 2, same negative 1 over 2. So that we have over here the third value of z. And also we'll have the same negative a, same positive a over here. So in the next step, so here instead of positive sign we'll have negative sign, instead of positive sign we'll have negative sign, and here we'll have positive negative sign, here we'll have negative sign, so here we'll have negative sign, here we'll have negative sign. So we have negative of square root of 3 to square root of 3 over 2 the whole square, and the right side also we have negative of square root of 3 over 2 the whole square. When I add square root of 3 over 2 the whole square on both sides, this one will cancel out. Again we'll be having the same equation and the same result, whatever result I got over here. So for the third value of z, so So whatever result I got over here so far, the same result I'll be getting. So we don't have to do that one. Okay, on the previous page, we got 4 order pairs for A comma B, which meet the conditions given in the question. So here, when you take the second value of Z, I got 6 order pairs. We don't have to verify for the third one. So for the third value of Z also, we'll be getting the same result. So in all, we get 4 positive 6, which is equal to 10. So we get 10 order pairs for A comma B. So the answer for the given question is 10.